So let us see integration of some particular functions. So in last class we have discussed few formulas as integral dx by the whole divided by x squared minus a squared, okay, a squared minus x squared plus a squared, and the square of all those terms. Okay, so all these we have discussed. But in today's session we'll be solving few problems of that particular type where we have, let us take one example as integral dx by 9x squared plus 6x plus 5. Okay, so this is a given problem. So what I'm going to do is that I'm going to use splitting the square method and I'm going to solve this. So this can be rewritten as 9 into x squared plus 6 by 9x plus 5 by 9. The same only I have rewritten. Hope this is clear. Okay. So then what I'm going to do is that once again I can use splitting the middle term, and what I'm going to do is that I'm going to just take this, already it gets cancelled, so 2 3s are 6 and this becomes 8 3s are 9. Okay, so simplified half of this coefficient of x I'm going to square, okay, and I'm going to add and subtract the coefficient of x term, that is splitting the middle term method. So what I'm going to do is that plus 2 by 3x plus half of this I'm going to add and subtract. Okay, what is half of this? Half of this will be 1 by 3. So square and subtract. I'm going to add and subtract. Okay, so hope you understand. So half of the middle term I'm going to square. I'm going to take it and I'm going to square the term and I'm going to add and subtract from the given. So this in turn becomes, okay, so this what happens, this 1 by 9 can be taken out, this remains as dx, and this entire term, okay, this entire term can be rewritten as, this entire term can be rewritten as x plus 1 by 3 the whole square. Okay, this entire term can be written as x plus 1 by 3 the whole square plus, okay, plus 5 by 9 minus 1 by 9. 5 by 9 minus 1 by 9 is 4 by 9. Okay, so this once again it becomes 1 by 9 into integral dx by x plus 1 by 3 the whole square plus 2 by 3 the whole square. Okay, so can you guess of which particular form the given formula is? Okay, so since we know integral dx by x squared plus a squared, okay, so what is the given form? Is equal to, what is the given integral? What is this particular form? Okay, it's nothing but 1 by a into tan inverse of x by a plus c. So this is the formula. This is the formula which we know earlier. Okay, so this is the formula which we know earlier. So using this formula, when you substitute, so in the place of x, I'm going to have x plus 1 by 3. So this becomes, so applying the above formula, we have, what is this actually? It is 1 by 9 is common. And what is the formal integral formula we have used? 1 by a. What is 1 by a? It's something called, okay, 1 divided by 2 by 3. 1 divided by 2 by 3. And what is here? 1 by a tan inverse of, what is x here? It is nothing but x plus 1 by 3. X plus 1 tan inverse x by a. What is a? Once again it is 2 by 3 plus, okay, 1 by a tan inverse x by a plus. So this once again can be written as 1 by 9. This becomes what? 3 by 2 into tan inverse of, this 3 also comes up. Okay, So 3 into 3x plus 1 by 3. 3x plus 1 by 3. Okay, the whole divided by 2 plus c. Okay, so this when it comes up, this because the 3 has come up, so 3 into 3x plus 1 by 3. So what I can do here, when I multiply here, this becomes finally 1 by 3. Okay, and this when you simplify, so this 3 and 3 get cancelled, so I am left out with this 2 also. I can bring it out, so 6 1 by 6 into this 3 gets cancelled. Okay, and this 2 also is the, okay, tan inverse of 3x plus 1 the whole divided by 2. Yes. So this is your final answer. 1 by 6 tan inverse of 3x plus 1 by 2. Yes. So this is your final answer. Hope this is clear. So this is one of the particular method. So you have to check whether the numerator is only dx, and it is of the form only dx and a quadratic. Immediately what should strike in your mind? You should use, okay, splitting the middle term method, and you have to add and subtract half of the coefficient of the x term, and you have to bring it off any of the standard forms which we have seen earlier. The 6 standard forms we have discussed in the previous session. You have to just use with those 6 formulas, and then we have to carry out the problem. So this is one of the first method, okay, in particular functions. So let me take another problem which is going to be a little different, which is of px plus q form. Okay, second problem which is going to be of px plus q form. So when the numerator is of the form px plus q divided by a quadratic equation, so what will be the case? So in this case, we are supposed to take the px plus q term can be equated to, okay, a into d by dx of the denominator plus b. So what should be done? Px plus q should be rewritten. That is a numerator. The numerator px plus q should be rewritten as a into d by dx of the denominator plus b. This is very important. Only the px plus q term is going to be rewritten like this. Okay, and then as usual, you will find out what is going to be a, what is going to be, then try to equate it, and then solve the given problem. Okay, so let me explain an example. And then below this is the form x plus 3 x squared minus 2x minus 5 dx. So this is of the form px plus q. This is of the form px plus q. Okay, numerator is of this particular form. Numerator is of this particular form px plus q, and then you have a recorded equation. So what I said, as per the formula, I said yes, you have to write x plus 3 is equal to a into d by dx of the denominator. What is denominator? X squared minus 2x minus 5 plus b. Okay. So what happens now? This becomes x plus 3 is equal to a into d by dx, differentiate 2x minus 2, this becomes 0. Okay, so plus b. So what I can do is that, okay, so either I want to just find the values of a and b. Okay, I want to find the values of what is going to be this a and what is going to be this b. So how to find the values of a and b is that either I can equate the coefficient of x everywhere, or I can just use some substitution so that the terms become 0. So now I'm going to equating the coefficient of x, equating coefficient of x terms, okay, on both sides. This becomes, actually it is 2ax minus 2a only. Here it is x plus 3. So equating the coefficient of x, this becomes 1 is equal to 2a. Isn't it? 1 is equal to 2a. So what is this? Which implies a is equal to 1 by 2. Okay, a is equal to 1 by 2. Then equating constants. What am I going to get? So this side I have 3 is equal to minus 2a, because minus 2 into a, it's minus 2a plus b. Already we know it's a is 1 by 2. So this becomes minus 2 into 1 by 2 plus b. Okay. So b becomes, from this, b is equal to 3 plus 1, 4. B becomes 4. Okay, so we have found the values of a and b. So then what I am supposed to do is that you have to substitute that value there. Okay, so the given integral, when it is of the form x plus 3 by x squared minus 2x minus 5, can be rewritten as a into d by dx of, isn't it? So a into d by dx. What is a here? 1 by 2. Okay, 1 by 2 into, okay, x plus 3 is equal to a into 2x minus 2 plus b, isn't it? So 1 by 2 into integral 2x minus 2, denominator is as it is, x squared minus 2x per 5 dx. Okay, only the numerator x plus 3 dx plus 2 is written like this. Okay, this is very important. This step is very important. So now after you find the values of a and b, where you are going to substitute? You are going to substitute only in this particular place. Okay, only in this particular place we are going to equate. So a into d by dx of 1 by 2 plus, what is b value which we have got? B value is 4, and this is nothing but integral dx by x squared minus 2x minus 5. Okay. So this becomes 1 by 2, and 2 can be taken commonly out. So this becomes x minus 1 by x squared minus 2x. Or we have it as it is, because when you take the substitution method, that will be easier for us to simplify, isn't it? So what I can do is that I'll just have it as it is, and I'm going to use substitution method. Here I can take, okay, x squared as t. So this I'll name it as I1. So this I'll name it as I1, and this I'll name it as I2. So now what I1 says, let us see what I1 says. So when I1 is nothing but 2x by 2x minus 2 by x squared minus 2x minus 5 dx. So what happens to this? This can be rewritten as, okay, this the t. Okay, so what I'm going to do here, let t is equal to x squared minus 2x minus 5, then dt becomes 2x minus 2, okay, 2x minus 2 into dx, isn't it? So 2x minus 2 can be written as dt by t. This becomes dt by t. So dt by t is nothing but log. Okay, so log of log t. What is t? It is nothing but which is equal to log of, okay, x squared minus 2x minus 5. Okay, so this is the I1. So I1 is this. dt by t is nothing but log of x squared minus 2x minus 5. Then what about the next integral, second integral, I2? I2 is nothing but, I2 is integral dx by x squared minus 2x minus 5. The previous what you have seen, that is you have to take out the quotient of the term, you have to add and subtract. Okay, so what I am going to do is that I am going to rewrite as dx by x squared. Okay, so this can be written as minus 2x, okay, plus half of the quotient is minus 1 the whole square minus of minus 1 the whole square minus 1. So this becomes integral dx by, what is this, x minus 1 the whole square, okay, x minus 1 the whole square, this x minus 1 the whole square. So minus 1 minus 5 is nothing but minus 6. So x squared minus a squared form. What is x squared minus a squared form? This implies integral dx by x squared minus a squared. Okay, here you check. Here I am adding and subtracting only. So the subtracted term is becoming minus 1 minus 5. Okay, so it's minus 6 only. So a is minus 6. So this can be written as root 6 the whole square. Okay, this can be written as root 6 the whole square. So a in this case becomes root 6. Okay, so this becomes, what is x squared minus a squared? One by 2a log of x minus a by x plus a plus c. So this can be written as 1 by 2 into root 6, okay, 1 by 2a log of, what is x minus a? So x minus 1, okay, minus root 6 by, okay, x minus 1 plus root 6 plus c. So this is your I2. This is your I2. So now combining I1 and I2, okay, let me have this as 2 and this as 3 and this as 1, okay, that is 1. So this is clear. So substituting both the values of I1 and I2 here, I will be getting the final answer. And that is your final answer. So I1 plus I2 put together with the constants, that will give you the final answer. So what will be your final answer? The final answer will be, what will be your final answer? It will be 1 by 2 into log of x squared minus 2x minus 5, okay, and then this will be this 4 into, this is 1 by 2, 4 by 2 becomes 2, isn't it? So 2 by root 6 into log of x minus 1 minus root 6 divided by x minus 1 plus root 6 plus c. So that will be your final answer. So your final answer is this. This is your final answer. Hope this is clear. The same only when it comes with a square term also. Okay, the same method only you are going to follow when it comes with the square root of the denominator. So a into d by dx of the denominator plus b. So whenever you have this px plus q form, you have to remember this formula. When nothing is there, only is only integral dx, you have to use splitting the square method. So these are two things which you have to remember in particular functions, integration of some particular function. The 6 formulas you should be very thorough such that you can use for integration.